Hello everyone, welcome back to my channel Gems of Knowledge. In my today's video, we are going to deal with the Sslc chapter electricity and the formulas related to it and formula related questions as a passing package. Okay, so just in case if you are new to my channel, please take a moment to subscribe to my channel and also click on the bell button to get the notification to the earliest. Okay, so here the first formula we are going to learn is formula for electric current. Okay, so electric current formula is equals to charge by time. So what is electric current is actually the charge, the amount of charge flows in that particular time, that itself is called as electric current. So according to the definition, its formula will be electric current is represented by the letter I, charge is represented by q, and time by t. So I is equals to q by t. So this is the formula. Okay, and related to this formula, let us solve one question. So just you need to remember that the whatever the question, whatever the numerical problems are being asked into your particular exams are already dependent from your textbook itself. Okay, uh, whatever the questions are, it comes from your textbook itself. Maybe the numbers can be interchanged. Okay, you just have to focus on the particular content what they are giving you, on that particular things, on that particular formulas only you will get the numericals to solve. Okay, so here the first question: a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Okay, so a current is being drawn from an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. We need to find the charge, that is Q value we have to find. So already they have given us 0.5 ampere, which is current, and time they have told us it is 10 minutes. Okay, we need to find Q. So this formula is applicable here. So first thing what we need to write is given. Always remember to write what is given into the question, so that it is easier for you to apply the formula. Okay, so current is given, that is I is equals to 0.5 ampere. Okay, then 10 minutes is given. What is that? Time. 10 minutes, you just have to convert this minutes into seconds, because seconds is the SI unit for your time. Okay, so we know that 1 minute is equals to 60 seconds. Okay, similarly 10 minutes will be equal to how much? Just cross multiply this. Okay, it will be 10 into 60. So the answer is 10 6 are 60, and the 0 will be as it is. So this is 600 seconds. Okay, so this will become 600 seconds. Now let us apply the formula. I is equals to Q by T. So I value is 0.5 is equals to Q, we don't know. We need to find out Q, and T is 600. Okay. So now what we will do is we will move this to this side. It will become 600 into 0.5 is equals to Q. This is divided by here. If we move this to this side, it will become multiply. Okay. Now this 0.5, 0.5 is half. Okay. So 2 ones are 2 threes are 6, 0 and 0. So Q is equals to 300 C. What is C? C is nothing but the SI unit of charge, that is coulomb. Okay, so this is just a single question I have solved regarding to this regarding to this formula. Okay, so there may be number of questions into the exercise which is similar to this formula. You can check it out and you can solve it. Okay, then moving to the second formula, formula for potential difference, and potential difference is also called as voltage. Okay, so what is the voltage now? It is the work done in moving a particular charge from one place to another place. Okay, when a charge is moved from one place to another place, whatever the work is done there, that particular thing is called as voltage. Okay, so dependent on that, we have formula V is equals to work done by charge, that is W by Q, where W is nothing but work done, Q is charge, V stands for potential difference, also it is called as voltage. Okay, now here question number 2, how much work is done in moving a charge of 2 coulomb? See, 2C is nothing but 2 coulomb. Okay, across 2 points having a potential difference 12 volt. So what is given here? Potential difference is given. Potential difference means V is given, it is 12 volt. Then charge is given, charge means Q, Q is 2 coulomb. What is the formula we are having? V is equals to W by Q. So just substitute, in place of V it is 12, which is equals to W we don't know, we need to find out. Q we are having, it is 2. Okay, now if we bring this 2 to this side, it is already divided by, it will become into 2 is equals to W. So 12 2s are 24. Okay, so it means W is equals to 24 J. What is J? J is nothing but joules. Okay, whatever the work is done is always measured in joules. So this is the SI unit of work done. Okay, so moving to the next question. Okay, so the next formula is formula for Ohm's law. Okay, this is very most important part of this chapter. Okay, the law, a related formula, and the related numerical problem to this Ohm's law. Okay, so the Ohm's law is V is equals to I into R. That is, whatever the voltage is passing through a particular wire, that is equals to the current and its resistance. Okay. Okay, so the formula is V is equals to IR. Okay, so the question is, how much current will an electric bulb draw? So they are asking us current. Okay, we need to find out the current. Will an electric bulb draw from a 220 volt source? When it comes to volt, we just have to remember it that V is nothing but voltage. Okay, then if the resistance of the bulb filament is 1200 ohms, when this sign comes, we just have to remember it is the sign for resistance. So R is equals to 1200 ohms. So what we have to find out? We have to find out I. So what is the formula? Okay, formula is V is equals to IR. Okay, let us substitute. V value is 220 is equal to I, we don't know, we will keep as it is, into R is, okay, so we will bring this to this side, it will become 220 is equals to I. If we bring this 1200 to this side, it will become divided by, because here it was multiply, after it comes to the left side it becomes divided. 0 and 0 cancelled. Okay, 2 ones are 2 ones are 2 6 are 12 and 0 as it is. Now we need to find, we need to divide it like this, 11 inside and 60. Okay, now 11 cannot be divided by 60, so what we will do, 0 with a point, here we will take 1 0. So 61s are 60, 62s are 120, here it is 110, so 61s are 60. What is remaining with us is 50 is remaining. Okay, so we can write directly the answer. I is equals to, here after cancelling, I is equals to 0.1 ampere. Okay, 0.1 ampere. Or else you may continue to solve this, including one more 0, this will become 500, and 6 8s are 48, we know the 0 as it is, so it will become 500 minus 480, 20 will be remaining, so this is 0.18 ampere. Okay, if you want more, you can solve it, you can continue it again. So we will stop here after the two numbers. Okay, next question. How much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohms? Same question, numbers are different. Here 1200 ohms has been given. Here 100 ohms is given. Same source value 220 volt and 220 volt. Same thing, you have to find out current and current. Okay, only the number is changed. So again the same thing, what is given? V is equals to 220 volt, R is equals to 100 ohms, I we have to find out. Okay, so the formula is V is equals to IR. So substitute, V value is 220, I value we don't know, we will keep it as it is, into R value is 100. So let us bring this 100 to this side. It will become 220 divided by 100 is equals to I. 0 and 0 got cancelled. 10 ones are 10 twos are 20. Okay, 2 is remaining. I'll show this into this manner. 22 was remaining and 10 is remaining. Okay, so 10 twos are 20. Again 2 is remaining. So I will put one point here and take one 0. Now 10 twos are 20. Okay, so the answer is 2.2. That is I is equals to 2.2 ampere. Answer is. Okay, next question number 4. The potential difference between the terminals of an electric heater is 60 volt. Okay, when it draws a current of 4 ampere from the source, what current will it enter if the potential difference is increased to 120 volt? So just see, this is a common question which comes in multiple choice. Okay, and 4 options are given and you just have to answer the option. Okay, so just using your brain, if I tell you that 60 volt current is voltage is been taken for 4 ampere. Okay, now they are asking what current it will get. Okay, if it is increased to 120 volt. Now 60 volt is increased to 120 volt, that is almost doubled. 60 plus 60 is 120. So what will be the current here? As this is increased to doubled, this also must be doubled. That is 4 plus 4 is 8 ampere. So the answer is 8 ampere. Now just we will see how to solve it. Okay, so first they have given us V is equals to 60 volt. Okay, and I is equals to 4 ampere. What we have to find out is R. Okay, according to the formula, V is equals to IR. Substitute the value. V is 60, I is 4, into R we have to find out. Okay, so just bring this 4 to this side. It will become 60 divided by 4 is equals to R. This is 4 ones are 4, 4 ones are 4, 2 is remaining, 4 5s are 20. So R will be equals to 15 ohms. Okay, now we got the resistance. Now what we have to find out here? We need to find out the current. Okay, in the second case, in case 2. Okay, in case 2, what is given? Only they have given us V is equals to 120 volt. Okay, what we got here, R value is 15 ohms. What we have to find out? I we have to find out. Okay, so V is equals to IR. V formula is, V value is 120. I we don't know, we have to find out, into R value is 15. Okay, okay, so bring this 15 to this side. It will become 120 by 15 is equals to I. Now we know that 15 ones are 15, 15 eights are 120. So what is the value of I? I is equals to 8 ampere. Okay, so if this question is asked for 3 marks, you can directly solve it into like this. If it is asked in the case of multiple choice, just apply your brains and you can solve it in this manner. Okay, I hope you have understood with this. So that's all for this video. If you are having any doubts regarding, you can comment me down below. I'll be back with the part 2 of this numerical problems. So till then, stay tuned and stay connected. Thank you.